Assalamualaikum warahmatullahi wabarakatuh. My name is Ilyasa Hakim bin Fauzi with number matrix 2020816538, and today I will present to you about my final year project 1. My topic is multi-parametric analysis of the plastic injection molding parameters in reducing product defect, which is a comparison between the central composite design and Latin hypercube sampling design sampling. And my supervisor is IRTS Dr. Kausalya Venkatason. So next is for the content of my presentation is first project summary, which is including introduction and background. Second is project background, which is including literature review, objective, scope and limitation. Next is methodology, and lastly, expected result. So for project summary, in this field of plastic injection molding, the quality of the finished product can be influenced by various process parameters such as injection pressure, mold temperature, and cooling time. These parameters can interact with each other and have a significant impact on the product's structural integrity and aesthetic properties. It is essential to identify and optimize the optimal process parameter setting to minimize defect in finished product. And one approach to optimizing process parameter is to use a multi-parametric analysis, which involve systematically studying the effect of multiple parameters on the product quality. The central composite design is a statistical design that involves the systematic variation of multiple process parameters around a central point. It allows for the identification of correlating and interactive effect between parameters, and it is suitable for analyzing continuous and discrete variable. On the other hand, Latin hypercube sampling is a sampling method that involves randomly sampling from a different parameter space. It allows for the efficient exploration of the parameter space and is suitable for analyzing continuous and discrete variables. In a comparison between the central composite design and Latin hypercube sampling, it may be found that one method is more effective at reducing product defect compared to the other. This comparison can provide valuable insight into the optimal process parameter setting for plastic injection molding and can help manufacturer improve the quality of their product. So next is project background. Injection molding is a popular method for producing plastic component at high production rate and with strong control over product specification. The size, stability, appearance, and mechanical qualities of the items are used to define their quality. Furthermore, different types of material contribute to the defect of plastic injection molding. Different types of material can also result in varying degrees of defect. Every material has properties such as melting temperature, density, and tensile strength. The wider context of the project is the plastic injection molding industry, which is a common method for producing plastic product. The problem that has been identified is the high rate of product defect in the plastic injection molding process, which can lead to costly rework or scrap as well as reduce customer satisfaction. As a result, selecting the right material is critical for reducing product defect. So for Latin hypercube sampling, it is a statistical approach for producing a new random sample of parameter values from a multidimensional distribution. The sampling approach is frequently used in the design of computer experiment. The dot bone shaped specimen will be examined to assist calculate and get the result by plotting graph. So next, there are three parts of project background, which is literature review, objective, scope and limitation. Next is literature review. LW So stated in his research that The mold and the component design of plastic part for injection molding is a complex process with factors ranging from cost and manufacturing speed to structural, ergonomic, and aesthetic criteria. The procedure of cavity balance is one of the routine that a designer must go through while designing quality into a part. This includes managing the plastic flow during the filling phase such that the matte front arrive at the most border at the same time. This is accomplished by altering the thickness of various portions, which may be a, which may be a time-consuming trial and error procedure. This study describes a way for automating the thickness adjustment procedure. Based on B. Osterlick research, because of today's competitive condition, which push us to manufacture quicker and cheaper with greater quality, such as lower patch, sync marks, and so on, having preliminary information about the procedure that will be conducted is required. To achieve this need, computer-aided analysis and engineering application are employed. Mold Flow Plastic Insight is a commercial computer-aided engineering program for the plastic injection process. This tool has been used in this study to get the ideal grip position, filling, and flow, and the warpage application for minimum warpage of plastic parts. And lastly, D.E. Huntington also stated in his research that there are two strategies that can be used to increase the performance of latent hypercube sampling. It is recommended that realization for each variable be obtained by calculating the probabilistic means of equiprobable disjunct interval in the various domain, rather than directly utilizing the cumulative distribution function as is currently done. So next is the objective of my study. Firstly is designing the dog bone shape specimen in Katia based on previous research measurement. Secondly, analyzing and recording the outcome of defect in the plastic injection molding of this specimen, which is dog bone shape specimen, and namely the shrinkage and warpage defect. Third is to compare the efficiency between central composite design and Latin hypercube sampling in the parametric analysis. And one more objective is studying the interaction of this parameter in the defect outcome of the plastic injection molding process through the mathematical modeling and optimizing the plastic injection molding parameter for reduced warpage and shrinkage result. Next is scope and limitation. So for the scope of my study is to find out the difference between central composite design and Latin hypercube sampling. For the limitation for the research is that only specified for dog bone shape only. Next is this research specified for four common parameter only, which are melting temperature, injection pressure, packing time, and mold temperature. So next part is methodology. So firstly, it has must has introduction. Second, problem statement. The design of experiment method was used to create dog bone shape. It must be performed by plastic injection molding. There are many parameters that be used in this experiment so that there is no specific result yet. So that is my problem statement for this study. Next is literature review. After literature review, uh, I must identify four objectives. So after identify the four objectives, I must do the objective, which is first design the OpenSheet in Katia. Second is analyzing and recording the outcome of defect in the plastic injection molding of this dog bone shape specimen, and namely the shrinkage and warpage effect. Third is perform the parametric analysis, and fourth is studying the interaction of this parameter in the defects outcome of the plastic injection molding process through the mathematical modeling. After that, I must do the data analysis and discussion. Firstly, obtain the graph for CCD and LHS, which is CCD refer to central composite design and LHS refer to 13 hypercube sampling. Next is expected result. So the right picture is the dot bone shape that I already designed in CATIA. I must design this dot bone shape by referring to the previous study because later I must compare the result between my result and before this. I also must follow the exactly dimension that previous study done. Next, so the picture below is the data collected from MATLAB for the central composite design. So before plot the graph, here is the data that I already collected, and the center point is run 8 times to reduce the correlation among the coefficient estimate. For the result, I also must use the Moleflow software. I already downloaded it, but after a few attempts to run, it is unable to run, and I already told my supervisor about this issue. So next is references. Here is my references that I use for this study, and so that's all from me. Thank you for your time also to hear my presentation. Again, thank you.